Hello, I am Nitika Verma and I am presenting a video on the topic Types of Inheritance and Virtual Base Class in C++. By the end of the video, we will know about inheritance, modes of inheritance, how to make a private member inheritable, types of inheritance, virtual base class, abstract class, and nesting of class. So first, inheritance. The capability of a class to derive properties and characteristics from another class is called inheritance. Inheritance is one of the most important features of object-oriented programming. It basically includes two terms, subclass and superclass. Subclass. The class that inherits properties from another class is called subclass. It is also called as derived class. Superclass. The class whose properties are inherited by a subclass is called base class or superclass. Let's move to the syntax of inheritance. First, we have to write the keyword class, then comes the name of derived class, access mode, or visibility mode, which can be private, public, or protected, then the name of base class. Then comes the body of subclass. Note, a derived class doesn't inherit access to private data members. However, it does inherit a full parent object which contains any private members which that class declares. Now we come to the next topic, which is modes of inheritance. First is private mode. If we derive a subclass from a private base class, then both public member and protected members of the base class will become private in derived class. Next is protected mode. If we derive a subclass from a protected base class, then both public member and protected members of the base class will become protected in derived class. Last is public mode. If we derive a subclass from a public base class, then the public member of the base class will become public in the derived class and protected members of the base class will become protected in the derived class. Now let's see how to make a private member inheritable. The image summarizes how the visibility of base class members undergoes modifications in all the three types of derivations. Private derivation means that the base class has been inherited privately. Public members of the base class are private within the derived class. Protected members of the base class are private within the derived class. Private members of the base class stay private within the base class, and these are only visible within the base class. In this part of a code, base class name is inherited in the derived class name using private access mode. Now let's move to the types of inheritance. There are 5 types of inheritance, which are single inheritance, multiple inheritance, hybrid inheritance, hierarchical inheritance, and multi-level inheritance. To get started, let's look at single inheritance. In single inheritance, a class is allowed to inherit from only one class. That is, one subclass is inherited by one base class only. In the image, class A is inherited in class B, and here is the syntax for single inheritance. Next is multiple inheritance. Multiple inheritance is a feature of C++ where a class can inherit from more than one classes. That is, one subclass is inherited from more than one base classes. In the image, we have two base classes named class B and class C, for which we have a single derived class, class A. Here is the syntax of multiple inheritance. Next is multi-level inheritance. In this type of inheritance, a derived class is created from another derived class. In this image, class C is inherited in class B and class B is inherited in class A. That is, class A is derived class for class B and class B is derived class for class C. Next is hierarchical inheritance. In this type of inheritance, more than one subclass is inherited from a single base class. That is, more than one derived class is created from a single base class. In this picture, we have two derived class for class G, which are class B and class E. Furthermore, class A and class C are derived class for class B and class D and class F are derived class for class E. Last is hybrid inheritance. Hybrid inheritance is implemented by combining more than one type of inheritance. For example, combining hierarchical inheritance and multiple inheritance. Let's have a look on a special type of inheritance, hybrid inheritance, multipath inheritance. A derived class with two base classes and these two base classes have one common base class is called multipath inheritance. An ambiguity can arise in this type of inheritance. Let's see how to avoid ambiguity. In multiple inheritance, there may be possibility that a class may inherit member functions with same name from two or more base classes, and the derived class may not have functions with the same name as those of its base classes. If the object of derived class need to access one of the same named member function of the base classes, then it results in ambiguity, as it is not clear to the compiler which basis class member function should be invoked. The ambiguity simply means the state when the compiler confused. Solution of ambiguity in multiple inheritance. The ambiguity can be resolved by using the scope resolution operator to specify the class in which the member function lies as given below. This statement invokes the function name ABC which lies in the base class A. Next topic is virtual base class. Virtual base classes are used in virtual inheritance in a way of preventing multiple instances of a given class appearing in an inheritance hierarchy when using multiple inheritances. Virtual base classes offers a way to save space and avoid ambiguities in class hierarchies that use multiple inheritances. When a base class is specified as a virtual base, it can act as an indirect base more than once without duplication of its data members. A single copy of its data members is shared by all the base classes that use virtual base. Now let's see, why do we need virtual base classes? Consider the situation where we have one class A. This class A is inherited by two other classes B and C. Both this class are inherited into another class D as shown in figure below. Note, virtual can be written before or after the public. Now only one copy of data member or function member will be copied to class C and class A becomes virtual base class. Let me show this by taking an example. In this program, if we don't use virtual base class, then there will be an error. Let us consider a situation in which we are not using virtual base class. In that case, both D1 and D2 inherit B. They both have a single copy of B. However, D3 inherit both D1 and D2. Therefore, D3 have two copies of B, one from D1 and another from D2. Both the statements will generate error as compiler can't differentiate two copies of B in D3. To remove multiple copies of B in D3, we must inherit B in D1 and D2 as virtual class. Now, D3 have only one copy of B and statement 4 will override the value of B given in statement 3. The virtual base class is used when a derived class has multiple copies of base class. Let's move to abstract class. Sometimes implementation of all function cannot be provided in a base class because we don't know the implementation. Such a class is called abstract class. A pure virtual function or abstract function in C++ is a virtual function for which we don't have implementation, we only declare it. A pure virtual function is declared by assigning 0 in declaration. A class is abstract if it has at least one pure virtual function. We can have pointers and references of abstract class type. If we do not override the pure virtual function in derived class, then derived class also becomes abstract class. An abstract class can have constructors. The last topic is nesting of classes. A nested class is a class which is declared in another enclosing class. A nested class is a member and such has the same access rights as any other member. The members of an enclosing class have no special access to the members of a nested class. The usual rules shall be obeyed. Thank you.